Okay, good afternoon, everyone. Today we're going to continue our discussion on where we left off. We were doing stepwise regression last time, and I told you to see what will be the final model, what will be the uh, predictors. Okay, may I have an answer from you, class? What was your final model? Anyone?
Sir?
Yes.
I stopped at mod 6 but I'm not sure with the ANOVA finding.
Okay, sige nga.
Tama ba yung mod 6?
Could you kindly share that, please?
Sige
Mod
po.
6, yeah. Okay, let me. Okay, there. Sige. So mod 6.
Opo.
So what are your
So,
predictors sa mod 6?
ano na lang po, education, tenure, and then gender.
Edu okay, education, tenure, gender. How about your mod number 5?
Um, yung variables is education, tenure, civil status, and gender.
Okay, okay, so who's this?
Fe po.
Fe, okay, Fe. Okay, so thank you, Fe, for, do not leave, Fe, no? Thank you for answering, but this is a very, thank you for volunteering, and I appreciate your courage to show your answer and share your answer to us. Now, may tanong lang ako, I have a question. Now, what variable did you remove here?
Yung sa mod 5 po, yung ni-remove ko is experience.
Experience. Pero wala na
Opo.
model
Ay,
5
you
na.
mean for mod 6? Ay, yung mod 6 po, yung ni-remove ko is civil status. I wasn't
Okay.
sure kasi for the asterisk na isa lang.
Okay. So, class, what does an one asterisk mean, class? Anyone, please? So, thank you, Fe, for allowing yourself to be used here as a point of discussion for the learning of the whole class. Anyone, please? Let's take a look at what Fe did here. Kasi what she did, 0.0129 yung P. Okay? What did we learn about 1 star P as far as R is concerned? Anyone, please? Class.
Ano po? As far as I remember, significant at 0.05.
0.05 or 5%, right? So this is significant at 5%. If you recall, what's the significance level that we're going to adopt in class? What are we going to use?
5% po.
5%. So, bali itong civil status, significant ba to? If we're going to base it on an alpha or level of significance of 5%.
Yes po.
Yes, so once again, Fer, thank you so much for your answer. Pero ito, no? When you get here, final model na yan. Kasi your civil status, which has the lowest t-value, if you compare the t-values among all the predictors, except of course yung intercept, no? So ito, you might have a different answer compared to Fe, no? Kasi kay Fe dito yung reference variable niya ginawa niyang si male, no? So yung gender female yung lumalabas siya kasi so most probably if you were still using gender male, you'll have a different intercept. Okay, magkakaiba ng intercept, no? Kung naiba yung reference frames natin. However, this will already be our final model. Okay, so no need to remove another variable kasi yung civil status natin is already statistically significant as it is. Okay? So thank you so much, Fe, no? Maraming salamat for sharing your answer. Okay, so is that clear, class? Is that clear, class, yung shinare ni Fe? Na the final model should be model number 5. Okay? Sige, let's have a quick review, class, and I'm going to share with you some codes, okay? And I'd like you to first, let's have a very quick review of what we have discussed so far. So we're using the wage data set, and our first model is a simple linear regression lang, no? We used education as the loan predictor because it has the highest correlation with hourly wage. Okay, please kindly install this package performance kasi gagamitin natin. Okay, so kindly install the package performance and then let's load it. I'll give you a few seconds. When you're done, class, when you're done,
Sir, hindi po kayo nakashare, sir.
ay, sorry. Okay, so this is what I was telling you, class. I'll just have a quick review of what we did before. So we imported the wage data set. We regressed hourly wage on education. Okay, that was our first model, our simple linear regression. And then I'd like you to install this package, performance package. Okay, and then please load it. And then once you have loaded it, let's take a look at some notes here. Okay, you can go here to here packages class, and then check if performance is there, and it should be checked already because we have loaded it. And then this is all about assessment of regression models performance. Okay. So the performance package is a very important package, especially when you're assessing the model, the regression model. Uh, the ones who crafted this, if we use the citation function, it will give us some information about the model itself, the package, I mean. So this was developed 2021 by Ludecky. Is the main, I think he's the main author. So it's an R package for assessment, comparison, and testing of statistical models. Okay, so it's a pretty good package. So if you go here to packages and then click this one, performance, you can see here, all right, some of the functions here are, you can check for autocorrelation. So this is for, especially when you're dealing with the time series, the residuals, and then check collinearity of your parameters. Then you have here, check heterogeneity, check heteroskedasticity. So there are many, check model itself also, visual check of me. This is to check for if we comply, if the model complies with the assumptions of classical linear regression assumptions, and then check normality, check outliers. So many things that you can check using the performance function. Okay, so if you get to the description file, these are the authors. So as I said, Lideke is the author and creator. So you have here Makowski, author and contributor, Ben Shakar. So there are quite a number of authors here. Okay, but the main creator is Ludeke. All right, then you can just check with CRAN the PDF which describes the different functions. All right, so just as a quick exercise, a quick example. So we created model 1 last time. Okay, this is just a solitary predictor. We have education. If we check model performance of model 1, if I run this, it will generate some information about measures about model 1. So we can find here, okay, you have the AIC, the Akaiki information criterion, then AIC corrected, BIC, R squared, adjusted R squared, Ramsey, and sigma. So these are the metrics that are used to to assess the model. Notice that these metrics do not make use of the p-values. Okay, it just measures the R squared, BIC, AIC, etc. Okay, I can also run this check model. So you have model performance. Then you may wish to also run this check model 1. And let's see what happens. What do you have here? If we check model 1, you'll find here the plots. So this is similar to the plots function that we were working on last time, the plot, for example, plot model 1. But I find this a bit better because it gives us some pointers to interpret. For example, posterior predictive check. So it tells us that the model, the predicted line should resemble the observed data line. The actual data point is the green one. The blue one is your model predicted. So based on the model, we can see here that there are some deviations. Okay, this is the predicted, and this is the green one is our observed value. So you can take a look at others. For example, when it comes to linearity, okay, so it should be flat and horizontal. Okay, can see it so much here. Just use this. So also, can check for heteroscedasticity, this one, and also for the presence of influential data points. All right, so etc. And this is we'll deal more with this when we go to the diagnostics for the final model. Okay, so that's those two functions, model performance and check model. All right, then what did we do last time, class? We also created the model where we're going to use all the predictors. Okay, for the first one, this is just a simple linear regression model because we're just using one predictor, education. So for model 2, we're using all the predictors. Okay, this is just a quick review class because we have already discussed this. So hourly wage associated with the dot here signifies that you're using all the predictors. So let me just run this quickly. And our model 2 is here, class. And we can compare model 1 and model 2. And we can see here that there are some insignificant parameters, and experience is just significant at the 10%. But there are three significant variables significant at the 0.1% level of significance. Okay, so then actually we determined if the variable is significant or not by looking either at the p-value or the t-stat. So we already discussed this on t-stat class. And then we can now compare, okay, we can use the compare performance. Okay, let's first use this, compare performance. And it will give us the metrics. For example, this is the name, model 2 as compared to model 1. Model 2 is the model with several predictors. Model 1 has only one predictor. Then model, they're both LM. R squared for model 2 is 0.37 as expected because model 2 has more predictors. And then model 1, the R squared is only 0.16. Also the R squared adjusted The Ramsey model number 2 is better because it has a lower root mean square error. Also, the sigma better is model 2. AIC weights. Now this one, this refers to weights, no? So this is not the AIC per se. AIC weights, and then this is AIC corrected. Okay, so this one now gives a weight between the two models. The weight for A, as far as AIC is concerned, gives us a weight of 1 for model number 2, and only a very small weight for model number 1. Same thing with the AIC corrected. 1 means 100%, which means in terms of AIC corrected, model number 2 is better. Then also in terms of BIC weights, take note, class, this is different from AIC, AICC itself, or BIC. You're not measuring here the Akaike information criterion. You are measuring here the weights. Okay, and the performance score is based on all of these parameters, 100% for model number 2 and 0% for model number 1. So in all aspects. So what we can do is, I'll just copy this here. We can append Control X. You can append here the plot function there. Plot, compare performance for model number 1 and model number 2. Rank is equal to true, which means we're asking R to rank it. So this is again from the performance package. So let's compare model 1 and model number 2 by plotting. This will give us a sort of a spider web plot. Okay, so here, how do you read this? The higher the value in the spider web, the better is the model. So in all counts, model 1, whether it's R squared, adjusted R squared, Ramsey, sigma, in all counts, the red is higher than the blue. So which means that in all counts, model number 2 is the better model compared to model number 1 in terms of these parameters. BIC weight, AICC weight, AIC weight, sigma, Ramsey, and R squared adjusted. Okay, let me pause for a while, and may I ask for your feedback or comments if I'm clear so far.
Sir,
Yes.
just to be sure po, um yung weights, the higher the weight, the better.
Saan weight?
Yung AIC weights and the
Oo,
BIC
oo.
weights.
The higher the better. Kasi di ba pinaparank natin siya. So it's not giving us the AIC itself. It's giving us the AIC weight. So let me run this again. But this tells us that in terms of weight, we're giving 100% na to, 1 eh. Ito very small, no? This is 0.0029 zeros and then 2 practically 0. So in terms of AIC, okay, we're giving a weight of 100% to model number 2. In terms of ranking, package, di ba kanina, ang package nito, kasi yung kanina, performance package, di ba I asked you to load this first. Yan, no? Okay, so may Dayan, paki-share mo yung answer mo sa iba. Dayan, kindly share your question to the others. Okay, my question si Dayan dito. She's telling us she's getting a different answer. All right, most probably, ano yung model number 1 mo, Dayan? Okay, I'll stop sharing. Could you kindly share your Stop share ako. Could you share your screen, please, Dan? Thank you for that question, Dan. And kindly share your screen, please. Okay, could you kindly go up? Ano yung model number 1 mo? Okay. Make sure model number 1. So that's your model number 1. Okay. Siguro din lang natin. I-run mo nga yan, please. Kindly run that, please. Okay, yun lang. And then let's go to model number 2. Kindly run model number 2. Yung model lang sana hindi mo na lahat. Okay, anyway. So that's model number 2, di ba? Okay. Go down. Sige, i-plot mo ngayon yung plot, compare performance model number 1 and model number 2. Oh, yan no. You must have run a different set of models. Okay, Dan?
Yes, sir. Thank you, po.
Okay, thank you. All right. Any other questions, class? Okay, please do not be ashamed to ask questions. Okay. All right. So when comparing model number 1 and model 2, we can see that in all aspects, mas maganda si model number 2 based on the parameters used in compare performance. All right. So let me now go to ganun din klase check model. It will give us the six plots, and these are very important. And we're going to discuss this more when we go to diagnostics, which is part of your case. Okay. Now for model number 3, okay. By the way, quick review again, class. Aside from this class, this one, it used R squared, adjusted R squared, AIC, AICC corrected, and then BIC, okay, then Ramsey, and then the sigma class. Those are not actually statistical tests, but we can now compare model 1 and model 2 using statistical tests via ANOVA. Okay, quick review class. Model 1 and model 2, what will be model 1 class? Model 1 will be in terms of restricted or unrestricted. Model 1 is your class. Model 1 is our, yeah, thank you. Thank you. Yeah, thank you. Yeah, thank you, Fed. All right. About the compare performance code, hindi lang may question dito. Ito, ano lang to, yung review lang to last time. So diniscuss ko lang to sa kabilang section kasi, okay, alright. Diba ito yung model number 2 natin, yan. Okay, diba sabi natin, how do we know if a parameter is statistically significant or not? We can use the p-value, okay, or the t-stat. Okay, yung t-stat. Paano natin malalaman kung significant? Using t-stat. Then you have to compute for the t-critical. All right. So what's a t-critical? Kailangan natin yung alpha 0.05. Tapos degree of freedom natin will be n minus k minus 1, where your k is 7 predictors. Kasi tinitingnan natin we're going to evaluate yung t-value dito. And this model has 7 predictors. 1, 2, 3, 4, 5, 6, 7. So we need the degree of freedom. Okay. So that's so ang degree of freedom natin, di ba? We're going to get the kasi two-tailed to, we're going to get the portion dun sa right tail. So this is 100% minus 5% over 2, that's 97.5%. And then the degree of freedom, we have already identified that. So ang t-critical natin dito 1.96. So we can use this now to determine, assuming kunyari wala itong p-value na to, we can check if this predictor is statistically significant. If it's higher than 1.96, then significant siya. Education, p-value 11.03. Okay, way higher than 1.96, then significant to. So consistent siya with the p-value. Ito, 1.96, di ba? Hindi siya lumampas ng 1.96. Therefore, hindi siya significant at 5%. Significant siya at 10%. So if you use 10%, magiging significant po. Tenure, greater than 1.96, so significant. Race, not greater than 1.96, so not significant. Gender, greater than 1.96, so significant. Civil status, okay, absolute value, this is not greater than 1.96, therefore not significant. Okay, but Adi, did that answer your question? Okay, all right, so thank you. Okay, then going back here. So based on the model number 2, say model number 2 natin. Okay, summary lang natin. Okay, what is the leading variable here? So we're not saying that our model will only consist of 3 significant predictors. Hindi pa tapos yan. Magsi-stepwise regression tayo, and we learned last time that the leading variable will be the one with the least absolute value ng t, which is race. So ito yung unang tatanggalin natin, ba? Right? So you can see here, ang model number 3 namin dito, tinanggal namin si race. This is just a repetition of what we discussed. Okay, so if we run this, sinama ko na yung summary dito sa simula. Tapos, you can see here now that ganun pa rin, tatlo pa rin significant. Si experience hindi pa rin significant. So what will be the leading variable here? Okay, wait. We can, of course, what we did to model number 2, we can do with model number 3. So in model performance class, it will just give you the measures. Check model, it will give you the plot and compare performance class. But let's just run itong plot ng compare performance para makita natin class. Okay, sige, run ko muna to itong compare performance. Okay. So ang hindi lang maganda dito class is that, okay, hindi magkasya yung ano yung result. No? Okay, so model number 3, this is the one with the less number of predictors. This is the restricted model. So in terms of R-squared, sino mas maganda? Halos pareho lang sila class, no? So kung i-plot natin to, tie sila, no? Si model number 3 at saka si model number 2. But in terms of adjusted R-squared, mas maganda si model number 3. Barely, no? Barely. So in terms of Ramsey, okay, parang 71% goes to model 3, 28% goes to model number 2. Kasi almost the same, siguro pag dinagdagan natin decimal places nito, mas maganda si model number 3 based on Ramsey. Okay, ganun din dito sa sigma. Okay, AIC weights, ang weight ni sa AIC mas maganda si model number 3. Ganun din sa model AICC, and then ganun din sa sa BIC, and then sa performance 71% ang weight for model number 3, 28% ang weight for model number 2. So mas matimbang class si model number 3, the restricted value, the one with no race. Yung tinanggal natin yung race, no? Okay, so if we now plot class. So once again, ito yung pinapakita kanina ni Dayan, no? Sabi natin sa adjusted sa Ramsey, mas better si model number 2. Sa BIC weight, AIC weight, AICC weight, etc. So kung sino mas mataas sa kanila, okay, mas better, no? Mas better lang si R squared si model number 2. R squared. Pero sa adjusted R squared, mas maganda si model number 3. Sa Ramsey, comparing, mas maganda si Si model number blue, model number 2. Okay, so this was what Dean showed a while ago. Okay, pause for a while, class. Questions, class? Any questions so far? Okay, I'll put it in the reverse. Are we clear so far? Paki-chat naman please kung clear so far yung discussion of the model performance at saka yung compare performance. Okay, thank you. Of course, ang disadvantage class ng ng compare performance is that hindi statistical yung basis, no? It's basing it on the metric. Now, we know class that we can do ANOVA, and model number 3 is the restricted model here kasi si model number 3 mas konti yung predictors. Tinanggalan natin to ng race, no? Si model number 2 is the unrestricted. So if we run this, yung ANOVA na to, okay, so si model number 1 is the unrestricted kasi may race siya. Si model number 2 dito is the restricted. Wala siyang race, no? So ang null hypothesis is that the restricted model is better. Now the probability that the p-value is 0.797. So this is greater than 0.05. So ang answer natin, we fail to reject the null hypothesis. Ano yung null hypothesis? The restricted model is better. Okay, which means class that it doesn't make sense to add race. Walang gamit yung race na wala siyang gamit na na parameter. So mas maganda yung walang race. So model number 3, which has no race, kasi tinanggal natin, is the better model statistically. Okay, pero dun sa plot natin, may items doon na mas maganda si model number 2. Alright, so you did this already. The leading variable is the highest, one with the lowest absolute value of t, which is number of dependents. No? So pag rinan natin to class, ang model number 4 natin, okay, ito na. No? So once again, ipag-plot ko class, didiretso na ako dito sa plot. I-plot ko model number 4 versus model number 3. Now you can see here that the model number 4 yung yung buga. No? So halos balance sila. In terms of yung sa R-squared, adjusted R-squared, mas maganda si model number 3. No? Ramsey at saka si Sigma, mas maganda si model number 3. So you can see here, hindi definite yung natin, weight ng BIC, AICC, AIC weight points to model number 4 as the better model. Okay, yan ang pinapakita sa atin ng compare performance yung plot. Okay, once again, sino yung mas maganda? Yung mas mataas, no? Kunyari ito. Ito AIC weighted, ito yung sa model 4, ito yung sa model 3. Right? So mas mataas si model number 3, so mas maganda siya. In fact, sa R-squared naman, tingnan nyo. Okay. Si dito, si lower yung R-squared ni model number 4. Okay, so mas maganda in terms of R-squared si model number 2. Okay? All right. So, but of course, we have learned also that statistically, pwede natin i-test yun. No? Model number 4 and model number 3. Ang restricted model nito is model number 4. Kasi wala siyang, diba, ang leading variable natin dyan, tinanggalan natin ng number of dependents. So model number 4 is the restricted model. If we do the ANOVA and p-value is greater than 0.05. So we fail to reject the null hypothesis. Failure to reject fail to reject the null hypothesis that the restricted model is better. Mas maganda nga in that regard, mas favorable si restricted model, yung tinanggalan ng number of dependents. because we cannot reject that null hypothesis. Okay, and lastly, so tinanggal si experience kasi it has the lowest p-value, and then we have this model. Summary natin. So take a look at this. Okay, nung tinanggal si experience, all the variables were now significant. Okay, so this is now our final model. Wala na tayong matatanggal. Okay, hindi tayo magtatanggal ng significant na predictor. Okay, and if we check class using the plot ng compare performance, okay, so compare natin si model number 4 and model number 5. Interestingly, class, okay, so from many aspects, si model number 4 yung mas maganda eh. R squared, adjusted R squared, Ramsey, sigma. Okay, so, di ba? Nakikita natin na mas maganda si model number 4. Si model number 5, ano lang siya dito sa PIC weight. But good thing, class, is that we have a statistical way to test that. Model number 5 is short. Restricted model kasi tinanggal natin si experience. So wag tayong sometimes yung model number 1 dito yung yung restricted, sometimes hindi. Pero ang importante pa sa ang null hypothesis natin, yung restricted is the better model. Once again, the p-value is 0.11, okay? 0.11, so 0.11 or 0.12, so it's greater than 0.05. Okay, and okay, by the way, may nagtanong kanina no? So, paano kung f-stat ang gagamitin natin? Ganun din, class. So, hahanapin natin control out I. We have to look for the F critical, no? And to compute for the F critical, QF tayo. Parang yung kanina QT, di ba? Pag ang hinahanap naman natin yung sa F, QF. There. Okay, so ano kailangan nito? Probability, degree of freedom 1, degree of freedom 2. Okay, kailangan ko yatang magsulat dito. Okay, so let me annotate. So ito yung F distribution natin. So ito yung hinahanap natin. F critical. Ang value ng F stat natin is 2.4. Okay? Alright, so anong natin? And ito class, one-tailed lang to. One-tailed. Okay, and since alpha natin is 0.05, so this should be, ito yung area under the curve natin, ito yung 95%. Okay, so let's compute for the F stat. Okay, anong hinahanap nito? Remove natin. So, QF, so E, DF1, DF2. Okay, so actually yun lang, pwede na yun. Yung iba mga default naman to eh. Okay, so ano yung P natin is 0.95, di ba? 95%. What's our degree of freedom 1? Degree of freedom 1 natin is ano yung degree of freedom natin? What do you think, class? Is it the number of predictors? Tingnan dito, class, oh. Ang degree of freedom 1 natin is 1. Bakit 1 siya? It's a difference between the number of predictors of model number 1 and model number 2. Ang model number 1 nating class, di ba? Ilan ang predictors? Ang model number 5 natin, 1, 2, 3, 4 predictors. Ang model 4 natin is 5 predictors. So ang degree of freedom 1 natin, yung differential is 1. Tapos what will be the degree of freedom number 2? Ilan class? Any guess? Anyone class? Ilan yung degrees of freedom natin? Will it be 521 or 520? Okay, actually it does not matter, no? Kasi pag gamitin natin ng 520, okay, let's see this. Okay, 3.85. That's our critical value. Okay, or if we use 521, okay, practically class, walang difference, no? All right, so this is our F critical. Ano yung F stat natin, class? Ang F stat natin is 2.42. Therefore, it's to the left of the rejection region. So, failure to reject to. And consistent with the p-value. P-value natin, we fail to reject kasi less than 0.05. Tapos si F-stat natin is 2.4. Ang F-critical natin is 3.8. Okay, so since our F-stat is to the left of our critical value, then it's in the non-rejection region. So we fail to reject that null hypothesis that model number, the restricted model is better than the unrestricted model. Okay, let me pause for a while. Any questions so far, class? Okay, clear ba? Pa-chat naman kung yes, yes or no. Sorry to include this kasi this was asked a while ago. Okay, so you're good. All right. So therefore, class, we know the final model, di ba? The final model is model 5. Ito na yung 4 na predictors. Okay? So, okay, we will leave this class ito. Babalikan natin to when we go to diagnostics. So let's first take a look at, okay, let me copy this. Let me put it in the chat box. Okay. Let me go here. Na doble yan. Tao dito klase. Saan ba nagsimula yung ano? Okay. Sige. Okay, I'll go here. All right. So let's first discuss class yung stepwise regression. So we're going to make use of this. I-load nyo muna to sa OLSRR. So this is the package that's used when we're doing stepwise regression. What we have done stepwise regression, right? But it's manual. What we can do is to make use of this package para automatic na siya. Hindi na tayo magma-manual na step by step because the OLSRR package can do that for us. Okay. So tell me please, i-recreate natin let's call it model number 10. This is just the, we're modeling hourly wage on all the predictors. Okay, so model number 10 is actually your model number 2. And please tell me, class, if you have done model this one. I can begin with the first function of OLSRR. Now, again, class, I would that you, okay, it would be great, class, if you can also check yung OLSRR. So this one, so it's tools for building OLS regression models. So that's the title of that package. Tingnan nga natin sandali yung citation ito. So for example, you're writing a paper and you'd like to cite yung citation for OLSRR. Okay, so ito pa pala na library, OLSRR. Okay. Kasi yung citation, sorry yung citation is not a generic, it's not a generic form function. It's only for, it can be used for some packages, but not all packages. I'm sorry about that. Okay. Sorry, I got confused here. So ito hindi pa pwede ito. No? Kanina yung sa performance, pwede natin gamitin yan. Kasi naka-load yung kayo sa performance package. All right, so what can you find, class, in the OLSRR package? A lot, no? A lot. So here are some of the some of the functions that we can use. So let's see, OLS forward, let's see. Saan si forward? Wala si forward. Sorry. Yan, OLS step backward, OLS step both, OLS step forward. Okay, so there are different there are different functions for OLSRR. So let's try some of them, class. Okay, the first one is this one, OLS step both. So anong ginagawa nitong OLS step both? Tingnan natin dito. Let's just OLS step both, and then it's either AIC or P or P.default. So tingnan muna natin to, class, no? I'm running here. Okay, this one. OLS step both P. If I click this, OLS step both P. So what will that give us? Okay, it's to build regression model, a set of candidate predictors, predictor variables by entering and removing predictors based on P values. Okay, tingnan nyo to, class, no? It says here step both. So, pwede siyang may i-enter at saka may remove. As distinguished from step forward or step backward. Kasi pag step forward lang, panay i-add lang. Pag step backward, panay i-remove lang. What we did was a stepwise na backward, di ba yung example natin? Kasi linode muna natin lahat, tapos one at a time tinatanggal natin yung mga least significant na predictors. Okay? So ito naman both, it can go either way. Pwedeng pwedeng magtanggal at saka pwedeng mag-add, no? Okay, so if we run this, okay, this one, OLS step both. Okay, ng model 10, we created this a while ago. Okay, so let me run this first. And it will give us a summary of what's happening in this model. Let me run this, baka sana pumasya. Okay, hindi pa rin kasha. But anyway, so ano nangyari dito, class? Magsisimula siya from nothing. No? So syempre, ang simula talaga niyan forward. So pinasok niya si education, ang susunod pinasok niya si tenure, ang susunod pinasok niya si gender, tapos ang susunod pinasok niya si civil status. So apat yung naging predictors niya. And the basis was, sabi dito, underscore P. For as long as the P value is less than 0.05, then either papasok or lalabas yung variable na yun. Tingnan nyo to, added or remove. Okay? All right, so this is now your OLS step both. No? We can also plot that. We can plot that. So let's create an object called K. So K is OLS step both P. And then let's plot K. Share ko na nga itong code chunk na to para mas mabilis. All right, kindly run that and let's see what happens. Any feedback, class? Ano nangyari sa model na yan? Pa-plot lang niya, class, yung ano, no? Yung nangyari, isa-isang dinagdagan yung model natin. Okay? And all of these are, kasi underscore P. So P method yung ginagamit dito. Dito. For as long as the P value of the model, of the variables included in the model are all less than 0.05, then ipapasok niya. No? Okay. If I run this, and plot ko si K, okay, so this is what happens. All right. So it compares, class. It compares ano nangyari sa R squared, adjusted R squared, when we're doing the stepwise, no? So you can see yung first variable, education, etc., etc. So tumataas naman yung R squared, tumaas yung adjusted R squared, the AIC, okay? And malo CP class, i-discuss na natin next meeting. Parang AIC to, the lower, the better. Okay, and then lastly, we also have here the SBIC and the Schwartz-Bayesian criterion. Schwartz-Bayesian information criterion and the Schwartz-Bayesian. Halos pareho lang naman yan. So you can see here, there are 4 variables kasi nga, yung model na to, yung OLS step both P generates 4 predictor variables. And all of them are all significant. Kasi P yung ginagamit natin dito. Okay, again, let me pause. Any questions about this, class? Can you tell me, class, if clear yun, yung apat, bakit apat, class? Kasi itong method na to, ito pinakita sa atin, ano, it will start from scratch. So, ang una talaga, kahit both, should be forward. So, maglalagay muna. Tapos sa, ano, class, sa both, pwedeng, pag naglagay ka na, pwede ka ulit magtanggal. Unlike sa forward, class, pag linagay mo na yung variable na yon, pinasok mo na sa model, hindi mo na siya pwedeng tanggalin. Yung both, pwedeng maglagay ka, tapos maglagay ka ulit, tapos pwedeng magtanggal, tanggalin mo yung linagay mo. So, ganun yung both, class. Okay, so, are we clear, class? Any feedback, please? Okay, so let's compare this with baguhin natin to. Let me share this with you. Kasi I think I used this. Tapos, random lang yung pag-discuss naman nito. So let me share this with you. And ang gawin natin class, i-compare natin. So let's create K1 na lang. Let's create K1, and then step both pa rin, both, and then AIC. So let's run this. So ang iba nito, no, OLS stepwise regression to. Again, both just like a while ago, pero AIC yung gagamitin natin. Kanina kasi p-value. So if I run this, okay. Take a look at this class. So ito AIC, pero iba yung result, no? So inad niya si education, inad niya si tenure, gender, civil status, si experience inad din niya. Okay, kanina nung p-value hindi kasama sa experience kasi experience had a p-value that's greater than 0.05. Ito class, for as long as AIC keeps on going down, ipapasok niya. Okay, so you can see here the difference between these two methods. No? Okay, si p-value method, i-allow lang niya na maging part ng model kung the p-value is less than 0.05. Ito, okay, experience here has a p-value that's greater than 0.05. Pero kasi ang basis natin yung AIC. So pinasok pa rin niya kasi bumaba yung AIC. Okay? All right. I hope that's clear, class. So yun ang difference nila, no? Okay. Then, okay, hindi pa natin i-discussion. Okay, dito na tayo. Okay, may question yata? Iba yung lumalabas sa ibang lumalabas na ano?
Yung sa backward po.
Backward.
Race and
Hindi pa ako
number of...
nag-backward, ha? Pinalitan ko kanina.
Okay.
Ginawa kong both, okay? Both. Okay, so sorry about that. Gawin yung both muna to. Para to compare lang yung both ng ano. Both to, no? Stepwise both. Pero, kanina kasi, OLS step both P. Ito ngayon, for comparison, OLS step both AIC. So sabi natin, magkaiba yung result talaga. No? Magkaiba yung result ng P at saka AIC. Sometimes, no? Hindi naman lahat. Okay, so I'll go here naman, no? Okay, ito. Stepwise backward regression. Actually, ginawa na natin. Okay. Control C. It's almost time, class. Let me just wind up and this last few codes. Okay. So hindi natin natapos ang OLSRR, tatapusin natin to sa Monday. Hindi mo tayo mag-quiz sa Monday. So kailangan natin matapos ang OLSRR para you can already start with your case. All right. Backward. Ito naman class. OLS step backward. Kanina, so maglalaro lang yan dyan, no? OLS step forward, OLS step backward, OLS both, tapos underscore P, underscore AIC. Ganun lang naman yan. So here, mag-backward regression tayo. Ito. Okay. If I run this, okay, tingnan nyo class. Ano nangyari? Backward to, no? All right. So, bakit isa lang tinanggal na? Elimination. Kita. Bakit isa lang? Ito na lang class. Ito yung i-run natin. OLS step backward P and then model number 10, then details is equal to true. Okay, tingnan nyo class. Mahaba ito class. Details is equal to true. So una class, kasi di ba backward elimination to, no? Di ba? So ang tanong, anong tatanggalin niya? What are we going to remove? So sabi niya, we are eliminating variables based on the p-value. So ang unang tinanggal niya yung race, which is what we did a while ago, di ba? Okay? So tinanggal niya yung race, ano mangyayari? Pag tinanggal niya yung race class, ito na yung magiging r squared kung 6 na lang natitira. Right? Then next. Yan, may ANOVA pa, no? Then parameter estimate. So very, very comprehensive yung ano na to. Okay, next. Variables removed, x. Tapos, wait. Bakit wala nang iba? Ano nangyari sa inyo, class? What was the next variable that was... okay. Kasi nag-redefine ako dito ng P is equal to 0.3. So, sorry, class, no? So, dapat dito P kasi PREM, sorry. PREM, no? Okay, P remaining. For a model to remain, dapat ang PREM niya 0.05. Bakit kaya nag-default na ano? Sorry, Okay, pakisama nito, class. Bakit kaya nag-default na 0.3? Ibig sabihin, default siya. Okay, just a few more seconds, class. So, paki-ano to, class? We're telling R that in order for a variable to remain, dapat ang ano niya, ang p-value is equal to 0.05. So, run natin to. Okay, tama na to. Alright. Kanina nagtataka ako bakit ano lang. So, una, tinanggal si race, tapos tinanggal si number of defendants, tapos tinanggal si experience. Okay. Alright. So, is this correct, class? Correct. Pareho ba ito ng ginawa natin kanina? Tinanggal si race, tinanggal si number of defendants, tapos tinanggal si experience. Ang natira 4 na lang, di ba? So, exactly the same. Alright? Exactly the same siya. Tapos ito, ganun din, class. Sama natin dito PREM is equal to 0.05. Then details, and I'll end in this class. Details is equal to true. Ito na, class, ipapakita na step by step. No? So medyo mahaba to, class. And I'll leave you, class, to analyze this. Okay, mahaba to, kasi ipapakita niya, class, kung ano nang nangyayari. So sabi niya dito, tanggalin muna si race, no? Which is what happened a while ago. Tapos ang susunod, after si race, tanggalin naman si numDep. Okay? Tanggalin si numDep. Tapos susunod, tanggalin si experience. Okay? So after that, after removing everything, no more variables satisfied. So ang tinanggal lang yung tatlo, race, number of dependents, experience. So it gives us the model summary. It gives us the ANOVA. It gives us the parameter estimates. Yun, yung mga variables na yan, education, tenure, gender, male, and civil status. Alright? Then elimination summary. Okay, so ito, class, yung stepwise regression. And good thing, meron tayong OLSRR para automatic, class, no, na ma-generate natin whether it's forward, step backward, step both. Okay. So paki-copy na lang po, class, itong si-share ko lang sa inyo para next meeting, para pareho kayo, class, ng kabilang section. Naulit lang to eh. Okay. Okay. Yeah. Okay. Paki-copy na lang. And then we'll complete this next meeting. Tatapusin natin tong stepwise. And then we go to diagnostics na. All right. So let me end our discussion for today.